This is question number 1 on JAMB Chemistry 2022. Question number 1 says the IUPAC name for this compound. They said the IUPAC name for this compound is, look at the option given to us. So before solving this question, let's look at this for clarification for us to solve the question. We look at this, you say, look at this. This met means 1. Met means 1. X means 2. Probe means 3. Boot means 4. Pence means 5. Hence means 6. Heft means 7. Oats means 8. None means 9. Dense means 10. Then now, we have alkane. Alkane was one of the member of what? Aliphatic carbon, aliphatic hydrocarbon. Aliphatic hydrocarbon produce alkane. Alkane is a series, is a family which we call homologous series under aliphatic what carbon. Look at his name, alkane. Look at the parent name. Ak is the general name. Ak, the general name. The parent name become N. N is the parent name. N. This parent name is what I will put here. When I put it here, I'm talking about what? Methane. Talking about 1 carbon. Because this methane, ethane, propane stand for the number of carbon. They are standing for the number of carbon. Butane means 4 carbon. But means 4 carbon. Pro means 4 carbon. 3 carbon. It mean what? 2 carbon. And methane, met stand for what? 1 carbon. So this is indicating the number of carbon. Are you clear with what I'm talking about? When I say pence, I'm talking about 5 carbon. Then now, if I'm not talking about alkane, this man will be substituted here. He become what? Methane. That's 1 carbon. Now look at it. Look at general formula for what? Alkane. General formula for alkane is this. When N is equals to 1, which is the first bond of alkane is N equals to 1, and it's called what? Methane. Have you seen it? Met for 1 carbon, A for what? Alkane. Then generally structural formula. Look at the structural. Look at the structure of what? Methane. Then when N is equals to 2. When N is equals to 2, look at the name. We call it what? Ethane. I've now used what? The parent name to what? Substitute for what? This man. He become the 2 carbon. I'm talking about 2 carbon now, right? That is the it. Then the parent name, N. Have you seen it now? Here I'm talking about 1 carbon. That means met. Then the parent name, N. Are you get what I'm saying now? Then now I come to what? Alkene. Alkene. This is alkene. This is alkene. This is alkene. E. Alkene. E. Alkene. And the parent name is what? N. In. That's the parent name. Then now I have this, the general molecular formula. That's the general molecular formula. When N is equals to 2, so you know that this first bond of what? Alkene is when N is equals to 2 is the first bond of alkene. And what do we call it? We call it what? Ethene. It's in. Have you seen it now? Then structural. Look at this structural. 2 carbon. And this means that it has double bond. You remember, this is double bond. Y is unsaturated hydrocarbon. Ethene is a what? Unsaturated hydrocarbon. Y alkane is a saturated hydrocarbon. So he has nothing to what? Lose. Then coming to this, that when N is equals to 3, that is the second bond of what? Alkene. That is the what? The second bond of alkene. And the name is what? Propene. Pro. You now put in. Pro-in. Telling me that I'm talking about what? Alkene. Then the structure. Look at the structure. You can put this double bond any place. I can put it here, I can put it here. So putting it here or here is immaterial. But one thing is that it must have a double bond to indicate that we are talking about propene. That's in, alkene. Then I decided to put my double bond here. Are you get what I'm saying now? I decided to put my double bond here. You can put it here. Then coming to this, I talk about what? Alkyne. This is alkyne. Look at the parent name. Yne. That's the parent name. Yne. Then the general molecular formula of the word alkyne is this. When N is equals to 2, when N is equals to 2, which is the first bond of what? Alkyne, then imply that what? The name is what? It's yne. Ethyne means what? Look at general, the structural. The structural means that it carries what? 3 bond. It has 3 bond. That's what? Yne. Then now when N is equals to 3 is the what? Second bond of what? Alkyne. And the name is what? Propyne. And look at the structure. You remember what I said again? That this triple bond can be here or here. I get what I'm saying now. If the triple bond came here, this hydrogen and hydrogen will leave here to come here to complete the what? The bond. Then now, you look at it, that's the structure. Then after this, you remember that this man is saturated. This is unsaturated hydrocarbon, which is what? Alkene. And alkyne is most unsaturated. Look at saturated hydrocarbon. This man is what? Unsaturated. This one is most unsaturated. Then now, let's go to this one. Alkyl group. We'll call it alkyl family. Alkyl family is also alkyl homologous series or family. Then the first general molecular formula for the alkyl is this. And how do we produce alkyl? We produce alkyl when alkane lose 1 electron. Come over here. When alkane lose 1 electron, look at the alkane general molecular formula. This place is 2. Then come here, you see alkyne. General molecular formula of alkyne is what? Here is 1. Meaning that alkane, when alkane lose 1 electron, we get what? Alkyl group. Then when N equals to 1, we have this man, which we call what? Methyl. And this is M. Methyl. That's the first bond of what? Alkyl series. When N is equals to 2, we have this. And what is the name? Ethyl. That's the second bond of what? Alkyl group. When N is equals to 3, we have this. And that's giving what? Propyne, which is what? This third bond of what? Alkyl group. You have seen that alkyl group is generated when what? Alkane lose 1 electron. And they are series. They are homologous series. Homologous series of alkyl group, homologous series of alkane, homologous series of what? Alkene, homologous series of what? Alkyl. This is alkyl. So note it now. Then right now let's go into it. For naming solution, how do we name solution? How do we name? To name this man, look at this. This is what they give me. H into the chain to CH3, and this to CH3, and this to CH3. To name this man, we first of all take the longest chain. And after we have taken the longest chain, we are going to number this longest chain such that the branch chain, the carbon carrying the branch chain, will have the least number. Get me right. First of all, we get the longest chain with the longest road. How did I do that? I started from maybe here, 1, 2, 3, 4. What am I counting? How many carbon? 1, 2, 3, 4. Or I follow this way, 1, 2, 3, 4. This is my longest chain. This is also my longest chain. Any road I take, assuming I'm taking this one as my longest chain, this might become what? My branch chain, my branch road, which we'll call attachee to the main road. This is a branch road. I have taken this man as my longest chain. 1, 2, 3, 4 as my longest chain. This become what? Attachment, which we'll call attachee. Then now, for me to name this man, now after I've taken my longest chain, I have to number it. I have to number this carbon atom such that the carbon carrying this branch chain will be the least number. The carbon carrying this branch chain will have the least number. Let's say I'm starting from here. I started 1, 2, 3, 4. You see that the carbon carrying this branch chain is carbon number 2. If I number it this way, 1, 2, 3, 4. You see that the carbon carrying this branch chain will be carbon number 3, which will not be the least number. So for me to number it such that the carbon carrying this branch chain will be the least number, I have to number it this way. I think you have gotten me right. So the correct way to number is from this place, to number it to this direction. I have 1, 2, 3, 4. And this carbon carrying this branch chain is number 2. So then what will I do? I will say the carbon carrying this chain is number 2. I will write number 2. That's to indicate the carbon carrying the branch chain. I will put what? Hyphen. And what kind of branch chain is he carrying? He's carrying a branch chain called what? Methyl. This is a methyl. I will now write methyl. After I write methyl, then what is my main chain? My main longer chain. How many are there? 1, 2, 3, 4, which we'll call butane. That's butane. And I have what? Butane. That means 2-methyl butane. These two telling me the carbon carrying this what branch chain, which is what? Methyl. And my parent name is what? Butane. And that's our answer. We can now go to our option. I will now see that the option number C is the correct option. I will say my answer is option C. Yes, this is question number 2. Question number 2 says the number of electrons in the valency shell of an element of atomic number 14 is option A, option B, option C, option D. That is what they ask us here. The number of what? Valency shell in an what? Element that has atomic number of what? 14. Then before we go to solution of this question, let us recall some certain things. The energy of an orbital increases in the order below. Look at the order of filling of the energy. After we have learned this, we will see that you can solve this without wasting time. We said the energy of orbital increase in the order. That means 1x. After filling the 1x, we get to 2x. After the 2x have been filled up, we go to 2p. After 2p have filled up, we go to 3p. After 3p have filled up, we go to 3x ammeters. After 3x have filled up, we go to 3p. After 3p have filled up, we go to 4x. After 4x have filled up, we go to 3d. After 3d have filled up, we go to 4p. After 4p have filled up, we go to 5x. After 5x have filled up, we go to 4d. After 4d have filled up, we go to 5p. After 5p have filled up, we go to 6x. After 6x have filled up, we go to 4f. After 4f have filled up, we go to what? 5d. This is how we continue to be filling them. And remember that what filled completely x orbital, which is this x, what filled it is it takes two electrons, maximum of what? 2 electrons. If you give him 1 electron, it's not yet filled up until he get that 2 electrons. When he get these 2 electrons, that's when the second man will started to be what? Getting his own food. This man take 2 electrons, this man will start to take his own after 2 electrons that was exceeded. Then we come to P. Look at here. P orbital takes maximum electron of 6. P orbital takes maximum electron of 6. That means 6 filled P orbital. This P, for me to fill it up, 6. You only get 6. It have been filled up. Let's come over here. D orbital. We have what? D orbital takes maximum of what? 10 electron. D orbital takes maximum of 10 what? Electron. Electron that fill D orbital is what? 10. Then F orbital. F orbital takes maximum electron of 14. That 14 electron fill what? Look at here. 14 electron fill what? F orbital. F orbital is filled by what? Maximum of what? 14 electron. Looking at this again, You see that what we have here is what? S orbital, P orbital, D orbital, and F orbital. What we have, look at here, we have what? X orbital, comma, and P orbital, comma, and D orbital, comma, and what? F orbital. What field is mine is what? 2. What field is mine is what? 6. What field is mine is what? 10. What field is mine is 14. That's what we said. That what will complete this man is what? 2. What will complete this man field completely is what? 6. What will fill this man is 10, and what will fill this man is what? 14. Noted. Then we'll come to note that. We want to recall the number of electron. The number of electron, valency electron, in the outermost shell. In the outermost shell. What we call an outermost shell? Valency shell. Outermost shell is called what? Valency shell, where an atom used to what? React. Valency shell of an atom. Come over here. An atom or what? Element. Either we call it atom or what? Element. Tells us the group the element belong to. That is what? The valency that at utmost share of any electron, any element, takes us where the what? That element belong, the group it belong. That's what we say. For example, we come to example. Look at sodium. He has an atomic number. This 11, which is given to sodium, is atomic number, not atomic mass. We are talking about atomic number of sodium is what? 11. That's what we use. That atomic number is also what we call what? Proton. And that the same that proton is what we call electron. This one number of electron, proton, what number of electron sodium contain. And this is the number of what? Proton in the what? Sodium. And this is what we call atomic number of what? Sodium, not atomic mass. So now we said here, 1x, he have filled up. He have not consumed 11. He have not consumed this total electron. He have taken his own portion, which is 2. Then 2x have taken his own. Electron still berekated. He 2p have to take his 6 maximum. Then 3x have to take the remaining one. Count it. 2, 2, 4, 6, 10. And the 1, making it what? 11. And this first place is called first period, which is period K. Then this and this joined together like this is called second period, which we call period 11, orbital 11. Then the last orbital, look at the last orbital here, which is what? M. And how many electron is in that last orbital? How many electron? 1 electron. Look at it. 1 electron is in the last orbital. You said the first period, second period. The first period, second period. The last orbital is containing only 1 electron. And what we call what? Atmos shell or valency shell electron is 1. That's its own atmos what? Shell electron. Atomos shell. Look at the atomos shell of this word. Look at atomos shell. Look at the word. Electron is contained 1. And so this tells us that sodium belongs to group 1. That's what we are saying. So sodium belongs to group 1. And this group 1 is called what? Alkali metal. Group 1 element is called what? Alkali metal. Then now number 2, example number 2, magnesium, which is equals to what? 12. 12 is the atomic number of magnesium. And is equals to, look at the first shell, take 2, maximum of 2, x. I've taken his maximum 2. Then second, 2x is taking his 2. And the 2p is taking his 6. Yet, electrons still remain. Check it, 2 plus 2, 4, and this 10. Electrons still remain 2. Then the what? 3x have to be filled up 2. And my first period is 6. My second period, as we did here, the second period is 6. And the last shell, which is the period, is what? 3x2. And the atomos shell electron is what? 2. We said atomos shell valency electron is what? 2. Then we now say, so magnesium belongs to group 2. And the group 2 is called what? Alkaline what? Earth metal. alkaline earth metal is called what? Group 2. So you have noted it now. This is the period. Well, if we ask you how many period is this sodium, how many period is this, the sodium? Sodium has what? 3 period. First period, second and third period. How many period is magnesium? 3 period. 1, 2, 3. And the atomospheric electron is it? Atomospheric electron is it. And number 3 says aluminium has atomic number of 13. We start 1x2, 2x2, 3p6, 3x2, 3p1. If you check it, this plus this plus this will give me 10. This plus this will give me 13. Then now, let us look at the period. The first period, second period, third period, which is the last shell. And the number of electrons in that last shell is 2 plus 1. Look at it. The number of electrons in that last shell, the last shell is what? 2 plus 1, which give me 3. And I said, atmosphere valency shell electron is what? 3. Atmosphere is same thing as what we call valency shell electron is what? 3. And that shows me that this man, aluminium, belong to group 3. Aluminium belong to what? Group 3. We tell that what? Electron that is the atmosphere takes oxygen, not the group the element belong to. Then let us look at number 4, which solve our question. Number 4 solve our question, which is silicon. Give me equals to 14 atomic number. And I said 1x2, 2x2, 2p6, 3x2, 3p2. Check the electron. 1t4, 10. This give me 14. And my first period, my second period, my third period, which is my last shell. And the number of electrons that is in my last shell is 2 plus 2. This is 2 plus 2, giving me what? 4. And I said the atmosphere valency electron is what? 4. Therefore, I cannot say that silicon belongs to group 4. And the atmosphere valency electron of this silicon is what? 4, as we said, is 4. Then looking at the question they asked us here, come back to our question. Come back to our question. It said the number of electrons in the valency shell of an element of atomic number 14 is, look at it, and the number of what electron in the valency shell, what do we say is it? 4. And our answer is what? Option D. You cannot say, my answer is what? Option D. And what does this thing mean? It means what we know from our secondary school, that the first shell is K, the second shell is what? L, the third shell is what? M, the fourth shell is what? N, and the fifth shell is what? O, and continue. That's what. Then look at this. I have a J, which has 52 atomic number. I have 1s2, 2x2. So look at how many period. I have first period, shell, K shell, L shell, M shell, N shell, and the what? O shell. Have you seen what I draw there? And that's what it means. The first period is the second period, third period, fourth period, and fifth period. That means this man fall at fifth period. He has a 50 what period. And what group does he belong to? Can we know the group he belongs to? I cannot look at the number of electrons at the last point. Look at their last shell. I have 2 here. 2 plus 10 give me 12. Plus what? Plus 5 giving me 17. 2 plus 10 plus 5 giving me 17. I have 17 electrons here. But I don't have a group called 17 group. The group we have is group 1 to what? Group what? 0. Which is what we call noble gas. I get what I'm saying, that group 0 called what? Noble gas, which we can call group 7. That's what we have, group 1 to group what? 0, group 1 to group 7. Then, but what I have there at my atmosphere there is what? For 17. But I can't have 17 group. Then what will I do? I have to split it into what? The orbit. And what's that orbit? I have the first orbit, which is what? 2, which is what? K orbit. Goes by what? 8, which is what? L orbit. And what remains after I have that is what? 7. What remains 7, which belong to what? M orbit. And this man now become my last electron in my orbit. Means that what? That this man belong, that means that what? J belong to group of 7 belong to what? Group 7. Group 7. That's what where you belong. This is the last of my words. Split share, which is what? 7. This man belongs to group what? 7. That means this man belongs to group 7. When will I do this? When I add the number of electrons and the exceed the group we support, because we have group 1 to what? 7. But what I have here is 17. That's why I go into it. Note that the number of electrons share. Note that the number of electrons share takes us the period the elements belong to. That is, the first period contains only 2 electrons. The first period, look at the first period. Come over here. Look at the first period. Only 2 electrons that is there. Are you get what I'm saying now? And we said, why the second and the third period contain 8 electrons each. Second and third period contain 8 electrons each. Look at it. Look at the second period. Period 2. How many electrons? Look at it. 2 plus 6, 8. That's what it has. Look at period 3. 2 plus 6. That's 8. Are you get what I'm saying now? Then we'll now come back to say number 2. Period 4 and 5 contain 18 electrons each. Where is my period 4? Look at it. Look at 10 plus 2, which is what? 12 plus 6, giving me what? 18. Then go to this. Give me what? 2 plus this. Give me 12 plus this. Give me what? 18. I think we are there. We now see that period 4 and 5 contain 18 electrons. While period 2 and 3 contain 8 and period 1 1. Then period 1, 2. Then we go number 3. Period 6 has 32 electrons. Assuming that period 6 your corner, what we are going to have there is 32 what? Electron. Why period 7 is incomplete? Because there is other element that we have not discovered. We now leave that period 7 for such element that have not been what? Discovered. So that's why we say period 7 is a what? Incomplete. Question number 3. Question number 3 says, the equation given to us, this is a reaction which we call reversible reaction. And what they give us here, what does this is telling us? This is a reversible reaction of oxygen and sulfur oxide. Then now, looking at it, what does this man indicate? Which is the enthalpy. Enthalpy. And is what? Negative. Look at it. Minus mean what? Negative. And these have tell me the condition of the reactant. This is the only one that tell me the condition of the reactant. And they said in the equation above, an increase in the temperature will shift the equilibrium position to, look at the options, B, C, and D. We have no time for that. When we solve, we now go to option and know whether we can be able to see the option that is correct there. Then looking at this is a reversible what? Reaction. And this man here, this enthalpy, have told me that this reaction is a what? Exothermic. Is a what? Thermic what? Reaction. This reaction is a what? Exothermic reaction. If this man is positive, he become endothermic. But because of his negative, is a what? Exo what? Thermic. But when it is positive, it becomes what? Endothermic. And again, what does this thing signify? It's telling me the condition of the reactant. The condition of the reactant. That's what this man is telling me. As this man is negative, he's telling me that this reaction, the condition of the reactant is a what? Exothermic, meaning that they are hot. The reactant is hot. That's what he's telling me. That exothermic means that this reactant is a what? Hot. While the product is a what? Cool. Are you getting what I'm saying? The reactant is hot, while the product is what? Cold. Assuming that this man is positive. If it is positive, that means it's endothermic. Endothermic means that what? The reactant is cold, and the product is what? Hot. So what this man is telling me the condition of the reactant, note it today. So as this man is negative, this is telling me that the reactant is what? Hot, which is the exothermic. Then if the reactant is hot and this man is cold, which is what? The product is cold. Then what will happen when we increase the temperature? If we increase the temperature, these people is already hot. These people is what? Cold. If you increase the temperature where people that is what? Hot and cold, you know that in this reaction, okay, note it, let me make it clear. Note it for now that this man and this man is in the same house, is in the same what? Is the same building. Both the reactant and the what? Product are in the same what? In the same cell. Are you getting what I'm saying now? So these two things are not in separate position. They are in the same cell. That's what we mean by what? Dynamic. That's what we mean by dynamic reversible reaction. They go in and go out. They are in the same cell. So this person and this reactant and product are in the same cell. Then you increase the temperature. Why this man is already hot, this man is cold inside the place. This man is hot, this man is cold inside the place. Who will enjoy that increase in temperature? These people will reject it because they are already hot already. Why these people, are you looking at what I'm looking at? Why these people will what? Will enjoy it because they are cold and you bring what? Heat. Increasing the temperature means that you are bringing heat. And what will happen? The reactant will enjoy it because they are, the product will enjoy it because they are what? Cool. They will enjoy it. And they will begin to go backward. That means the backward reaction will be favored. Because as these people are enjoying it, they will get hot and come back to these people. While they are cool, as you are firing it, increasing the temperature, they will be coming over to become what? Hot. That means increasing in temperature will favor backward reaction. Increasing in temperature will favor what? Backward reaction. And when it favor backward reaction, what will happen to equilibrium position? Equilibrium position will shift to the what? Left. Instead of shifting to right, it will shift to left. And what will happen to the what? The constant, equilibrium constant? It will decrease. Because equilibrium constant, as you are firing increasing the temperature, is supposed to be going to what? Reactant, going to the product. Product supposed to be forming. Instead of product to form, what happened to the product? It start diminishing, meaning that what is decreasing. I get what I'm saying. The product will start diminishing, going to reactant as you are firing the what? Temperature. So what happened? Both the what? The equilibrium position will shift to the left, and the product, which is what? The equilibrium constant, will what? Decrease. So our option, based on what I've explained now, we'll look at it. We said the increasing the temperature will shift the equilibrium position to what? Equilibrium position to what? Left. We have confirmed it. It will favor the what? Backward reaction. And the equilibrium constant will what? Decrease. Yes, it will start decreasing. Then looking at this, left and the equilibrium constant will increase. No. You can't be firing something to go for product. Instead of to go to product, it's going backward to reactant. And you will be classifying it increasing. No, it's decreasing. So now, right, it will what? Go to right, and they what? No, this one are off. I get what I'm saying? They are what? Off. This man will go to what? Left. And the equilibrium constant will what? Decrease. Our answer, the option to our answer, the option of our answer become A. That's our answer is option what? A, which is what? Left, and the equilibrium constant will what? Decrease. You noted it today that this man is telling me the state of what? The reactant. If they don't want to tell you this, if they don't want to give you this, they will tell you that whether the reaction is endothermic or what? Exothermic. If they mention exothermic, it means that this man is negative. If they mention endothermic, we know that this man is what? Positive. So that's another way to tell you the condition of the reactant. If they want to mention endothermic or exothermic, they will give you what we call enthalpy. Enthalpy, the state of randomness, which will be what? Negative or positive. And that will give you the state of what? Reactant. Remember that both the reactant and the what? Product are in the same cell. I get what I'm saying now. They are in the same cell, but they are feeling different feeling. They have different feeling. They are in the same cell, but they have different feeling. In this case, these people are hot, these people are cold. I get what I'm saying? When this man is positive, these people will be what? Cold, these people will be what? Hot. So you will not know when you increase temperature who is going to benefit it and who is to be favored. That's question number 10. Question number 10 said, two elements P and Q with atomic numbers 11 and 8 respectively combined chemically to form the compound XPXQX substitute Y. That is the P substitute X and Q subscript what Y. The respective value of X and Y are, they give us option. Look at the option they give us. I'm not interested in the option until I solve what is given to me. Then now what we are looking for X and Y, and they give me the atomic number of each of them. The atomic number, can we go to solution? Solution without wasting time, solution, because JAMB, there's no delay. P is equals to 11, that's what they said. And the electronic configuration of P becomes 1x2, are you get what I'm saying now? And 2x what? 2, and what? 2p, 6, and what? 3x, 1. Are you get what I'm saying now? This man is 1. And the other person is giving to me Q. That means if I'm taking this man like this, my first period, my second period, and the last period, and I have the last electron there is 1. That means this man is in group 1. That means P is in what? In group what? 1. And it has a valency of what? It has a valency of what? 1. It has what? Valency of what? 1. That P has a valency of 1. It's in group 1 and it has what? A valency of 1. Then I go to what? Q. And Q is given to me to be what? 8. I think so. That's 8. And I would say that is 1x2 and what? 2x2 and 2p6. That give me what? 2p4. This will be 4 to make it 8. This is a 4 plus 2, 2 plus 2, 4 plus this give me 8. You cannot exceed. I have period 1 and my period 2. How many electrons are here in the last period? I have 2 and 4, which give me what? 6. That means this man is in group 6. That means Q is in group 6. Is in group 6. And it has a valency. It has a what? Valency of 2. It has a valency of 2. Somebody will say why? Why? Valency of what? 2. His valency is what? 2. Why? He has a 6 already. What he needed to complete his octet state, which is what? 8. To complete this man 8, he needed 2. That means what he needed is what? 2 electrons to complete what? Each octet state. If you put 2 electrons here, it will become what? 6. 6 plus 2 give me what? 8, which is octet state. And this is not mental. He cannot give out electron. Rather, it will what? Accept. Is a beggar. Are you what I'm saying now? Why this metal P is a giver? Why this man now is a beggar? He's already up to 6 electrons on his what? Atmosphere. What he needed to complete his octet state, which is what? 8, is what? 2. Why this man in his atmosphere he has only 1? For him to be able to get extra 7, oh God, he's like going, just moving to German, there's a high mountain. So it will be hard for him. Rather, it will be easier for him to give that one away and come to his octet state or duplex state. We have 2 states of what? Element. Other element is in a duplex state, which is this portion, or octet state, which at this point. I mean, I'm saying we have 2 stable states for what? Element, which we call duplex state and what? Octet state. Duplex state means 2. And octet state means what? 8. I get what I'm saying now. So now, this man can easily give out his 1 electron to come to his what? Octet state. Have you seen it now? Then why this man, it will find it difficult to give out 6 electrons. Why he needed only 2 to complete it and make it what? Octet state. So his valency now is 2 electrons, which he needed, not what he's giving out. What he needed is 2. So its valency is what? 2. Then, reaction now. For this man to react with P is coming with 1 valency. While Q needed 2 valency and they want to react, what will happen? The 2 will times what? P. That means that P is going with what? 2. And Q will go with 1. Q now needed 2. If Q needed 2 and the 1 is and the P is providing 1, you know that P will only provide 1 electron. So for P to make Q to be satisfied, he needed to double himself. Are you get what I'm saying now? P is providing only 1 electron. That's what he has. So and the P and the Q needed 2 electrons. Then what happened? For P to be able to be equal to Q, he has to double himself. Double that 1 electron he has to be able to be equal to what? Q. So that's why you see the 2. Then 2 will times what? The P. And the 1 which P has will times what? Q. And we will have this. And that implies that what? P to Q, which is 1 here. And what does it mean? And that what they told us that P is the what? From the reaction they say P is what? X. And the Q is what? Y. That implies that my what? X is equals to what? 2. And my what? Y is equals to 1. I can go to my option and check. That imply my X is equals to 2 and Y is equals to 1. I think you are seeing it. Come over here. That implies that what? My X is equals to 2 and Y is equals to 1. That's what we did here. And when I go to my option, I can now see that my option now become what? This one will now become 2 and the what? 1. That's what I mean, 2 and the what? 1. Going to the option now, you see that my option what? C. That my answer. My answer is what? Option what? C. Come back to what I said here again. Can we explain this more? I said P can give out what? 1 electron. Look at it. And the Q required 2 electrons. If P is going to give Q electron, that means P have to double itself. That's what we do here. He doubled himself. Can you see here? He doubled himself. Why Q will have only 1. Are you get what I'm saying? And that implies 2Q. Are you get what I'm saying? Then this man is what? X and the Q is 1, which is Y is 1. And that's how we get to it. There is question number 6. Question number 6 gives us this reaction, which radioactive reaction. This react with this giving us this. They said in the reaction above, X is a little neutron, helium atom, deuteron atom. I don't know. Let's go to solution before I can know the one that is the correct option. Solution. Then we'll look at this. I have this. Look at what they give me. I can write this like this. 14 and this 7 plus this X. I can call this man what? N. Call this man M. Then that gives me that 17 oxygen 8 plus 1 and what? 1. What does it mean? It implies, this means that 14 plus what? N. 14 plus N is equals to 17 plus what? 1. That's what it implies. And that implies that what? N, making N subject of formula, it will be equal, so this 14 will go over there. Already 17 plus 1 will give me 18. Minus the 14 coming over. Are you get what I'm saying? Huh? I said 14 going over here. 17 plus 1 have already given me 18 there. Why 14 coming over here is subtract. And N gives me what? 4. That means my N is 4. I go back again to say 7 again. 7 plus what? M is equals to 8. This 8 plus what? 1. This 1. And that implies that's 1. Making M subject of formula, I have M is equals to 8 plus 1 is already 9 over here. This 7 coming over here will be minus what? 2. And I will have that my what? M is equals to 2. And what does it mean? It implies that my what? X, which is what? M. N is here, which gives me N is 4 and this one is 2. And it implies that is what? That should be helium. That's this man, helium, which is 4 and what? E. and I see it that my answer is a what? Option 1. C is my answer, which is what? Helium atom, which has a what? This man to be what? 2, and this to be what? 4. That's the what? Helium. And my answer is what? C, which is what? That's question number 7. Question number 7 said an element X has electron configuration. Look at the configuration of that element X. Which of the following statements is correct about the element? Look at the option there. They said an element X has electron configuration. Look at the configuration. Then I said which of the following statement is correct about the element? I don't know. I look at the options there. I don't need to worry myself over the option. I have to go to what? Dissolving it before I will not know which one is the correct what option. I go to what? Solution. I go to solution. Looking at it, what they give me is what? 1x2. Applying the knowledge of what we have learned, 2x what? 2. And what? 2p6. Are you going to say that? And what? 3x what? 2. And 3p what? 5. That's what they give me. And this is my first shell. This is my second shell. And this is my last shell. And the number of electrons in that last shell is what? This man and this man. Are you getting what I'm saying? The number of electrons in the last shell is 2 plus what? 5, which will give me 2. Plus what? 5 will give me what? 7. 2 plus 5 give me what? 7. That means 7 electrons is in the atmosphere, which told me that this man belonged to group what? 7. And since he belonged to group 7, what does it mean? He's a what? Halogen. I get what I'm saying now. Anyone that belongs to group 7 is a what? Halogen. An element that belongs to group 7 is an what? Halogen. That means this man belongs to what? Group. His group is what? 7. And the group 7 is what? Halogen. Halogen is a group 7, which we'll call a natural what? Gas. Then look at this. Option A give us the word, the correct word answer. He said it is a what? Halogen. Other option has put in word grammar. The halogen is what the man is. My answer is a what? A.